Good morning friends. Today we are going to start the competitive of next topic, that is the oscillation. Friends, here we are going to see the combination of all kind of the questions. So let us begin with the first question. The first question says that which of the following is an essential condition for the motion of simple harmonic? Option A, constant force. Option B, force is proportional to the displacement. Option C, force is opposite to the displacement. Option D, force is proportional and opposite to the displacement. So while studying the theoretical part, we have seen that the linear SHM is a periodic motion in which the restoring force is directly proportional to the displacement, but both are in the opposite direction. Based on that sense, we can say F directly proportional to x, F is equal to minus k into x. So the option D is the correct, that the force is proportional and opposite to the displacement. So you can observe that the F directly proportional to the x, F is equal to minus kx. So minus sign will indicate that the force and displacement are in opposite direction. Okay, so this is the first question. Now move to the second question. The dimension of force constant under root force constant upon mass are same as that of option A, velocity, option B, angular velocity, option C, acceleration, option D, angular acceleration. Okay friends, so this question is based on the dimension. So here we should know the dimensions of the force constant. Force constant upon mass. If you are clear with the dimension, then you will get the answer of this question. If you don't know the dimension, then you will find some difficulty here. So F is equal to kx, so k is equal to F upon x. Using that formula, you can find out the dimension. While studying the theoretical part, I have told you how to find the dimension. So here, the dimensions of force constants are 1 in mass, 0 in length, and minus 2 in time upon mass. So mm will be get cancelled out. So we are getting under root t raised to minus 2, and if we take the square root, t raised to minus 1. T raised to minus 1 is a radian per second. That are the dimensions of angular velocity. Velocity has the dimensions meter per second. Angular velocity has dimension per second. Acceleration meter per second square, and angular acceleration radian per second square. So here radian per second and radian per second square. So our option B is the correct. Angular velocity has the dimension same as that of the square root of mass force constant upon mass. So option B is the correct. Friends, observe how we have calculated answer. We have written the formula under force constant upon mass. Then we have substituted the dimension of force constant. They are 1 in mass, 0 in length, and minus 2 in time. Here we will be getting answer the square root of t square. We have got the t raised to minus 1. That is the radian per second are the dimensions of the angular velocity. Radian do not have any kind of dimensions. Per second is t raised to minus 1. So option B is the correct answer here. Okay, now we will move to the third question. The third question says that differential equation of a particle performing SHM is given by. Differential equation is given to us d2x upon dt square plus 2x is equal to 0. The frequency of oscillatory motion is 2 upon 5 per second, root 2 upon 5 per second, a upon root 2 pi per second, 1 upon root 2 pi per second. Okay, so friends, as this is a differential equation, so we should know the standard formula of the differential equation. So we know the formula d2x upon dt square plus omega k upon m into x is equal to 0, and that is omega square x is equal to 0. That is a modified formula there. Now we have to compare this formula with the given formula d2x upon dt square plus 2x is equal to 0. If we compare these two equations, what will be our conclusion? That omega square is equal to 2x. So omega is equal to under root 2x, right? What is asked in the question? That the frequency is asked there, right? So this is the angular velocity. But what is omega? Omega is equal to 2 pi n. In the place of omega, we can write the 2 pi n is equal to root 2 into x. So n is equal to, we can take the 2 at the denominator place. So we are getting at the root 2x upon 2. So root 2x upon 2 pi. Now what is the 2? Root 2 multiplied by root 2. So in that, based on that, we can get the answer as a x upon root 2. X upon root 2 pi. Okay. So x upon root 2 pi. Now here they have considered the displacement x as a symbol a. So our option number C, x upon. So here you can observe that what is given in the equation, frequency of oscillatory motion is. So frequency I am going to repeat here once again. So how we have calculated there. So friends, here d2x upon dt square plus omega square x is equal to 0. So compare this equation. So d2x upon dt square plus 2x is equal to 0. So friends, here not necessary to write the 2. So you can cancel the 2. Otherwise, many students will get confused there. So here we are getting the 1 upon root 2 pi. So 1 upon root 2 into pi. So option number D, 1 upon root 2 into pi. That is the correct option. Friends, here x will be get cancelled there. So omega square is equals to 2. So omega is equals to root 2. But omega is equals to 2 pi n. So n is equals to root 2 upon 2 pi. So final answer is a 1 upon root 2 into pi per second. So friends, here we have seen the three important questions. I hope you have understood this equation. Okay friends, now we move towards question number 4. A body of mass 0.5 kg performs linear acceleration. Its displacement from the mean position is 0.5 meter. A restoring force of q Newton acts on it. The value of force constant is. So here we know the formula that F is equal to K. Now in given question the force constant is asked here. So K is equal to F upon X. Now what is the value of force? The value of force is 2 Newton. And X, what is X? X is the displacement, and the displacement is 0.5. So if we multiply the numerator and the denominator, we are getting the 20 upon 5. So 5 4s are 20. So the force constant will have the value 4 Newton per meter. So option number B will be the correct. Friends, in order to confuse you, the value of m is given. So lots of students will think that as mass is given, so we should apply the mass anywhere. But remember, as per the question, mathematical formula is F is equal to K upon X. So K is equal to F upon X. F is a force is given, divided with the displacement, that is 0.5. And after dividing, we are getting the final answer as option number B, that is 4 Newton per meter. Now we move to the next question. That's the question number 5. The amplitude of a harmonic oscillator is 5 cm and period pi. The maximum velocity of oscillating particle is option A 5 cm per second, option B 8 cm per second, option C 10 cm per second, option D 2 cm per second. So what is asking in the given question? The maximum velocity. And we have studied the formula for the velocity, that is v is equal to omega under root a square minus x square. For the maximum velocity, x is equal to 0. So Vmax of the formula a omega that we have studied theoretically. So that formula we have to apply here directly. That is Vmax is equal to a multiplied by omega. Now as per the question, the amplitude of oscillator is 5. So we can write here 5. Omega is equal to 2 pi upon t. And as per the question, what is the value of the period of pi second? In the place of capital T, we can write the pi will get cancelled there. So 5 multiplied by 2. So the final answer is the 10. So option here 10 centimeter per second. 10 centimeter per second. So option number C will be the correct answer. So friends, here we have applied the formula Vmax is equal to A omega. A is the amplitude and omega is equal to 2 pi by t. Now we move to the question number 6. The question number 6 says the particle execute SHM with a period t seconds and amplitude small a meters. The shortest time taken to reach a point a upon root 2 from its mean position in seconds is option A t, option B t upon 2, option C t upon 8, option D t upon 16. Friends, this question is very important. It is asked in the various competitive examination. So friends, if we read the question, then we will understand that the shortest time taken to reach the a upon root 2 from the mean position is. So here we will use the formula of the displacement, that's x is equal to a sine omega into t. What is the value of the shortest time taken we have to calculate, and the displacement will be given here a upon root 2. So a upon root 2 is equal to a sine, in the place of omega I can enter 2 pi t into small t. Okay, now a will be get cancelled there. So 1 upon root 2 is equal to sine 2 pi t into t. But sine pi by 4 is equal to 1 upon root 2. So we can write here sine pi by 4 sine 2 pi capital T into small t. Sine will be get cancelled there. Pi will also get cancelled there. So 1 upon 4 is equal to small t upon here 2 will be there capital T. Now we want the value of small t. So it will becomes t by 8. So small t is equal to t by 8. So option number C will be correct here. Friends, I am going to repeat this question once again. Here x is equal to a sin omega t. This formula we are going to use. Here what is the value of x? A upon root 2 is equal to a sin. What is the value of omega? 2 pi upon capital T into the small t. But a will be get cancelled out. 1 upon root 2 is equal to sin 2 pi upon capital T into small t. But sin pi by 4, sin 45 is equal to 1 upon root 2. So here we can substitute the sin pi by 4. Sin will be get cancelled, pi will be get cancelled. So 1 upon 4 is equal to 2 into small t upon capital T. If you do the cross multiplication, finally we are getting small t is equal to t upon 8. So here, friends, we have completed the 6th question. Try to solve such kind of the questions. Thank you. Have a nice day.